All right, let's take a look at box and whisker plots. These are one of my favorites, partly just because I feel like people think they know what they are and how to use them, but a lot of people don't. Also, this is actually a joke here. I don't know if you recognize that. One year, student thought this was actually a real thing, that there was a box and beard plot. There's not. Box and whisker plots are used. There's no such thing as a box and beard, but I like this little cartoon. So anyway, box and whisker plots are also sometimes just called box plots for short. And so we're going to take a look. Canvas, if you've noticed in your as you've poked around, does have a box and whisker or box plot tool. And so here's some data I have from Math 112 from the spring of 2019. And this is actually coming from the first exam, geometry and measurement, and this is coming from the second, area and volume. And so you might notice at first that we're missing, it seems like we're missing a whisker here, right? We'll talk about why in a second. This is a box and whisker plot. It's okay the way it is. It's fine that it's missing a whisker. This one has a very tiny whisker here, and maybe a tiny whisker here. It's a little hard to see. But let's talk about why. What does this mean? What's going on? First of all, if I asked you, which exam did students do better on, the geometry and measurement or the area and volume? I'm guessing you would say they did better on the geometry and measurement for no other reason than this one's farther to the right than this one. And you would be right, okay? If I asked you, why do we have this line here and this box? What's this box telling me? Hopefully you know, but I found a lot of students don't, and that's okay. So let's just talk through what's going on here. First, maybe I'll just give you some thoughts and definitions. Encourage you, if you haven't, to read in the textbook. There's a lot of really great information there. But box and whisker plots are really setting up a measure of position as well as showing some variation at the same time. And so we're looking at quartiles of data. You already know the second quartile, but you know it as the word median, okay? And so in your typical box and whisker plot, you're going to have a box with a line in it somewhere, and then you're going to have two whiskers. So what's really going on here is this is the median. The line in the box is the median, which we can also think of as the second quartile, and I'll talk about what that is in a second. Then on either end, you have the first and the third quartiles. And then here, you have the max score and the minimum value of your data set. Okay? Now, the first quartile corresponds to what we call the 25th percentile, and that's the data point, so that 25% of the data is below that number, and the rest is above. Third quartile then is, so 75% of the data is below the 75th percentile, the rest is above. The median is the same as the second quartile or the 50th percentile, 50% above, 50% below. Now, another term you'll see is the interquartile range, okay, the IQR. And that is the distance between the first quartile and the third quartile. So that distance is IQR, interquartile range. And that's used to show how spread out the data is. So let's go back here to this data. You see, if I was to ask you which data is more spread out, I think pretty quickly you would say the area and volume data is more spread out. Excuse me, that was a yawn. And so you see here, the interquartile range shows that as well. The interquartile range from here to here compared to here is much shorter in the geometry and measurement assessment. All right, so let's jump back into here. What is this? Do you remember? That's the median, so I don't really have labels. So if this is 75 and 100, I'm going to split this into fifths. And so this is 75, 80, 85, 90, 95, 100. And so we see the median score here was actually probably about a 98, which is fantastic. We see Q3 here, looks like it must have been about 99 or 100, which means that Q4, you see it's so small, it might have been about 99 or 100 as well. And that's why there's not a whisker on that side. Q1, then here is about 93. And the lowest score was 74. Okay. Now, one common mistake that's made that I want to point out here is, on past exams even, I've asked, why is this whisker longer than this? Okay. And a common answer that students give is, well, there's more people in here, so this is longer. That's not right. Because these are quartiles, that means a quarter of the people are in here, a quarter of the people are in here, a quarter of the people are in here, and a quarter of the people are in this little line right here. Okay, so there's not more people here. There's the same amount of people here as there is in the other parts. It just is more spread out. So, key point, the bottom quarter is more spread out. Than the top quarter. And this really gives us an idea of where people are at without actually seeing a display. So instead of looking at a histogram, I guess this technically is a display, but instead of looking at a histogram of the data and looking at all the scores, we can get a box and whisker plot pretty quickly to see what's going on. And so you can see if you are looking at a box and whisker plot, you can quickly see, okay, the median here is much higher. Many students, half the class, was 98 or above. That's fantastic. Here it's a little more spread out. Half the class was 93 or above. Still pretty decent. Here we have the bottom quarter of the class between 50 and 75. The lowest person scored a 50. Highest person scored 100. And so that's hopefully helpful for you in understanding box and whisker plots. We again have the lowest, the first quarter, so quarter of the data is here, quarter of the data is here, median here.